Okay, it's recording now.
Right. Welcome, everyone. My name is Farhad Dastoor. I'm an educator in the psychology department at Kwantlen Polytechnic University in Vancouver, Canada. I'm also the principal investigator at KPU's Virtual Reality Lab. To begin, I want to acknowledge that the 5 campuses of KPU are located on the unceded and traditional territories of the Kwantlen, Musqueam, Katsi, Semiahmoo, Tsawwassen, Kikite, and Coquitlam peoples. In the Halkomelem language, the name Kwantlen means tireless runner. In 1981, Grand Chief Joe Gabriel of the Kwantlen First Nation granted our institution permission to use the Kwantlen name. Today, we speak that name with pride, and we commit to building relationships with all First Peoples based on honor and respect. I'm very excited to host today's talk by Dr. Nithikul Nimkulrat, Associate Professor in Material Art and Design at OCAD University. This is talk number 3 in our VR speaker series. The plan of this series is to host 1 talk per month on topics that explore augmented, virtual, mixed, and extended realities, and to showcase their diverse applications in health, education, art, industry, entertainment, research, and social justice. Our talks are designed to be accessible to people no matter their experience level, and we will always give ample time for questions and discussions. These talks will also be recorded and posted on our YouTube channel, which you can find on our website, kpuvrlab.com. The VR Lab was founded in 2019, supported by a KPU Creative Capital Fund grant. We have dedicated space, equipment, and our lab members include student research assistants, practicum students, honor students, faculty, and alumni. Current lab members include Calvin Campbell, Tina Charmchi, Zerlinda Chow, Kieran Dogra, Kayla Garvin, Simi Kaur, and David Murray. If you're interested in a creative collaboration with us, please contact me at farhad.dastoor@kpu.ca. I would now like to hand over the event to Simi Kaur, our moderator for today.
Hi, thank you, Dr. Dastoor. Hi, everyone. Welcome again to the KPU Virtual Reality Speaker Series. My name is Simi Kaur. I am a practicum student for the Virtual Reality Lab and also a research assistant. I would just like to remind everyone that the talk would be recorded today, and if you choose not to be on camera, so please go ahead, turn off your camera and mute yourself. After the talk, there would be ample time for you guys to ask questions. At any time, if you would like to ask any questions, we will keep the questions anonymous. You can go ahead and post all your questions in the conversation in the chat box, and I will read them out anonymously. If you do choose that you would like to use your mic and ask a question, you can raise your hand, and that's the little icon on top of the screen that says a smiley face and a hand. At that point, I will call out your name, where you can go ahead, turn on your camera, unmute yourself, and ask your question yourself. And now, with pleasure, I would like to introduce today's talk of craft experience through digital fabrication and virtual reality by Dr. Nithikul Nimkulrat. The talk presents Dr. Nimkulrat's exploration of transformation analog form into digital one, using a range of techniques, including 3D scanning, CAD, virtual reality, 3D printing, and slip casting. These activities act as both a survey of digital fabrication capabilities and a way of exploring new thinking mechanisms offered by this emerging form of practice. The exploration seeks to broaden our understanding of the maker's role within the capabilities and limitations of digital interface and fabrication. A little bit about Dr. Nimkulrat. Dr. Nimkulrat intervenes research with textile practice, focusing on experiential knowledge in craft processes. Before joining the OCAD University in Canada as an associate professor in material art and design, and currently acting chair of the program, Dr. Nimkulrat worked at the Estonian Academy of Arts in Estonia, at the Loughborough University in United Kingdom, and Aalto University in Finland, where she earned a doctorate. She is the main editor of Crafting Textiles in the Digital Age and CoDesign's journal special issue on experiential knowledge and collaboration. So now I would like to go ahead and pass it over to Dr. Nimkulrat.
Okay, thanks so much, Simi, for your introduction, and thanks, Farhad, for your invitation. It's my great pleasure to be able to give you a talk today. And this talk is based on my collaboration between myself, who is an analog craft practitioner, and a digital craft practitioner. And this project was taking place during my sabbatical from my professorship from my previous institution, the Estonian Academy of Arts. So I was at Aalto University of Art and Design in Vancouver, your neighbor, and spent 2.5 months there. So basically this talk will be about that. So to begin, I would like to play you a short video clip that basically features the whole process of how I sort of explore different digital tools and in order to translate handcrafted objects into digital ones. So to tell you a little bit, my collaborators' backgrounds. So myself, I work extensively in textiles, mixing experimental and traditional forms of hand knottings to produce three-dimensional artifacts. And in this slide, you can see a few examples of my work. And I have used this hand knotting technique for over 15 years. And this is my collaborator's work. His name is Aaron Osterin. He's a glass artist who is fluent in computer-aided design and digital fabrication processes, and he applies his digital skill to mold making for glass casting. He is also the manager of the digital fabrication lab at Emily Carr. So a little bit about what this talk will cover. This talk aims to illuminate ways in which digital tools can be used to translate handcrafted objects in collaborative craft practice, addressing two questions. First, what forms of knowing and meaning making evolve in collaborative research through design practice? And second, what does it mean to explore material in computer-aided design through virtual reality? So I divide this talk into different sections. And the first section is about handcrafting through digital tools. So in order to translate handcrafted object using digital tools, of course, I need a handcrafted artifact to start with. So I decided to handcraft a small artifact using paper string as material for experimentation with digital tools in the lab. So basically, the artifact was based on my previously created work 10 years prior. It was called the coffee cup, made in 2007. So to think of which tool to start, so I came across 3D laser scanning. And in this case, it's about the use of handheld 3D scanner. It seems to me the most straightforward tool to start with, because I needed to use my hand to scan my handcrafted object. So I went row by row to scan the object. And interestingly, the scans could capture very well the quality of my cup, because the scans could resemble the characteristic of paper string and the handcraft. However, the files themselves were too large to process effectively in CAD. So basically, the scan caused all the computer in the lab to crash, including the manufacturing computer that was meant for the 3D scanner. So basically, I couldn't move any forward into any 3D modeling program just because of the file size. So I revisited, or started to think, oh, how to deal with this problem. So I returned to the very basic skill of everyone in the art and design field, which is freehand drawing. So I used drawing on Illustrator to draw on a photograph of the cup. And then I imported a section of knots that I drew into a 3D modeling software. And at that time, I used Cinema 4D as the CAD program. And by using this method, I could avoid the unmanageable data of the file. And a CAD model of three-dimensional array of one section of the knotted pattern could achieve a resemblance of the original knotted cup. And throughout the process of developing the CAD model, communication between my collaborator and me was very crucial, as we had very limited knowledge of each other's domain. So we had to continually find ways to understand intention and speculate on the next steps of the process. So we sometimes use like demos, like recording of what we want to do, or sometimes we drew. So I highlighted this because these are like very fundamental tools in learning and teaching design and craft. And this was my workstation. I used a stylus to draw and to manipulate the 3D models on a Wacom tablet. So handling a digital tool to interact with the CAD program resonates with Clark's and Chalmers's extended my thesis. The idea that the mind is not necessarily contained within the brain or physical body, but can extend to elements of the environment. In my case, the mind extended to the virtual software and the hand to the digital tool. The next section is about the uncertainty and imprecision of in digital fabrication. So once I could complete a CAD model, so we move on to printing it. And with my very little previous experience with digital output, I assume that a high level of precision and certainty would be enabled through digital fabrication. However, the processes presented challenges very similar to craft processes. So for me to start using 3D printer, it's very important to better understand the capacity of the materials and the tools in relation to the delicate cup form. So I started by setting details of the CAD model as small as 0.4 millimeter and use only partial support material. So if you imagine 0.4 millimeter, it's just very tiny, like just tiny. So the printer very surprisingly managed to print the entire model, but the physical print was too fragile to retain the cup form. So the next step was about exploration of like what would be the right thickness for this cup. So I gradually modify and test printed the 3D model in different thicknesses in order to find the right thickness or thickness that was suitable to the capacity of the machine, but at the same time could preserve the characteristics of knots, likeness of string, and fidelity of hand knotting. Once the thickness was decided, it was used to print different composite materials, including wood and copper. So in experimentation with these different composites, several iterations of setting parameters of the printer's slicing software were changed to explore the material's properties. For example, in this slide, you can see the incomplete and the complete print of the cup using wood composite filament. So in this case, the speed of printing the wood composite was gradually increased in order to achieve a better flow of the filament, because this filament is very fibrous, so it caused clogging to the extruder nozzle very easily. So by setting it to move faster, so I could achieve a complete print. And these are examples of 3D prints using different materials. And printing the 3D model of the cup in various composite filaments allow for a detailed comparison of the printed outcome. So what you can see in this slide from left is copper print. And interestingly, it's very heavy in comparison to the next print from right, which was printed using wood composite. The wood one is very light. And interestingly, the materials still play a very important role in the appearance of the print. Like, for example, in the wood print, you can see that the wood fiber really reveal itself very clearly in the print, unlike the one next to it, the black and the white ones. They were printed using biodegradable PLA filament. So like very smooth lines could be achieved, but with the wood one, it's impossible. So to be able to compare the resulting prints somehow resonate to what Sennett said. By making something happen more than once, we have an object to ponder. variations in that conjuring act permit exploration of sameness and difference, practicing becomes a narrative rather than mere digital repetition. So although the 3D printed cups could capture the likeness of the original hand-knotted cup, I felt at that time that something was missing. So basically the physical characteristic of knots, including continuity, flexibility, and bendability of knots, are things that string does well, were missing from these prints, because these prints are very rigid objects. So to move to the next step, I aim at representing the nature of knots more. So we attempted to create a new CAD model of flexible, loose knots, which brings us to the next section about handcrafting in virtual reality. So before I kind of entered virtual reality, I wanted to create flexible loose knots. So I employed just exactly the same methods, like freehand drawing on the tablet, using stylus on Illustrator, a section of knots. I just started with the very same process. And then once I imported the drawing into the CAD software, I found something very challenging, because to virtually knotting on a 2D screen was completely incomprehensible for me. Well, it didn't sufficiently depict the positions and the interlacing of strands that constructed knots. You can see over here that this part should be interlocking with this part, but on a 2D screen, I just couldn't manage to do it. So my collaborator, when seeing me struggle with this, he simply said out of blue that, why don't you draw in VR space? And funnily enough, he had no experience in VR himself, but it was just that at that time, Emily Card was just moved into the new building, and his neighboring lab was a VR lab. So we moved to the next lab. So I could try drawing in VR space. So I drew knot structures in a 3D VR space. Basically, I imitated a gestural manner of my real-world hand knotting of string. And very interestingly, drawing in VR recall hands-on experience and relational understanding of positions of strands in three-dimensional space that I usually have with hand knotting, but I couldn't find that when working on a 2D screen. So in a way, I found a solution for making a CAD model of a section of knots. So you can see here that I drew, I explore how knots are actually constructed in 3D space using VR. And from there, I could create a 3D model of a section of loose knots. So now the knots are constructed. As you can see the interlacement here, which I couldn't achieve by using a 2D screen and a stylus alone. So this was the part that I sort of visited VR space. So it was a really immersive experience. I just felt like I regained my ability to create something three-dimensional again in that space. So it was really interesting. And from there, after I could achieve this 3D model of loose knots, I move on to printing. And again, there's a challenge in terms of printing, just because when knots are constructed, there tend to be a lot of steep angles. So the printing nozzle disturbed on a previously printed area with a steep angle, and cause it to shift from its original position on the support material. And that resulted in the detachment of the next printed layer. So once the support material was removed, like over here, after the support material was removed, so this part was detached and of course went missing. So a lot of iteration to adjust the 3D model itself, and also the parameter setting in the printer slicing software, like the speed of printing, the density of support material, and also the angle of support material. After several iterations, I could get like a complete print, like in the white one. So after that, creating multi-sectional loose knots just became very easy. So I just did it and printed it. So here's the last section of this talk before coming to the conclusion. So it's about new craft, the digital meets the analog. So at the digital fabrication lab at Emily Carr, there was a powder printer there. But at that time, 3D printing technology in the beginning of my residency there didn't really attract me, because it seemed unrelated to my practice, because it's about creating something very, very solid, very rigid. But after accumulating my 3D modeling skill and also 3D printing skills, I saw this technology as new opportunity to give function to my artifact. So just to tell you a little bit, like, although being a textile practitioner by profession, I had gained in my bachelor degree in industrial design an understanding of the general principles of mold making for prototyping and traditional ceramics. So together with my collaborator, who is an expert in CAD and digital fabrication digital fabrication processes of mold making for glass casting, I could create a CAD model of a two-piece mold for slip casting. And in this case, I'm going to use porcelain to cast my cup. And in this image, you can see how the mold was like completed from the printer and was about to be removed from the printer. So after the mold was removed from the printer, so there was some processing, like spraying some water and let it dry to increase the material's plasticity. So once the mold was completely dry, I slip cast porcelain into it. And the material that was used to print is of higher density than like traditional plaster used for like molds in ceramics for slip casting. So I had to let the clay slip set in the mold significantly longer than normally. Like normally, you can leave porcelain in a mold for half an hour, and in this case, I left the slip in the mold for more than 24 hours, so significantly longer. And here is the cast cup, and if you look at it, you can see the texture that is inimitable, and this texture is an imprint of how the mold was constructed layer by layer. like the powder is accumulated layer by layer, and it was visible on the mold, and it was transferred onto the surface of this cast cup. And my collaborator, by sitting on the outside, watching my gesture as I utilize the VR interface to generate knotted vector line form, he became interested in using VR himself. So he speculated a connection between the gestural and fluid motion traditionally used in his own class practice and the immersive gestural interface of VR. So he tried to employ VR to imitate his gesture in that usually embedded in his own class practice. So a little bit of gesture. Gestures by one individual can outline an intentional object and bring perceptible points of the world to the attention of another. Gestural acts cross borders, providing nonverbal invitations for others to take part in dialogue. So this part is my collaborator's work. So he went into VR and drew this part. And then he created a three-dimensional glass form and a mold for casting glass. So in a way, this work captured his gesture in the VR space. So this is how the mold looks like from the printer. So after post-processing the mold, like normally, like spraying and letting it dry, so he filled the mold with crushed glass and fired it so that the glass melt, and then he could achieve the fluid form. And this is how the object looked at the end. So the novel form and surface generated here are impossible using traditional glass casting and blow molding methods. So what is made is only possible using digital fabrication methods and the drawing practice in the VR space. So the use of 3D printed molds for casting glass and ceramics reduces time and waste. So as there is no need to create an original positive form as required in traditional casting methods. And this is a flow chart showing the acts of hybridization that requires translation. So the flow of translations between the the analog language and the digital language, as shown in the diagram here, provide new opportunity and understanding by way of gestural, manual, and tacit knowledge. And in this flow chart, you can see that, I started the process with completely analog gesture by creating this hand knotted cup. And then I move on to employ analog and digital gesture in the matter of drawing on the tablet and CAD modeling and drawing in VR. And then the gesture was translated via digital process and digital tools again when printing it. And then again, gesture was translated back into material in order to achieve all these material objects. So this is just to show that gesture can be moved back and forth between analog and digital ones. So back to what the two questions that I posed in the beginning. What forms of knowing and meaning making evolve in collaborative research through design practice? And what does it mean to explore material in computer-aided design through virtual reality? So the use of new tools, efforts, new outcomes, and new material meanings. An embodied understanding of these meanings is gained by being close to the material as it changes from one state to another. Here, meaning, as we understand it, is not the product of representation, but the product of a conceptual integration between material conceptual domains. When creating loose knots on flat peripheral devices, the implicit meaning of the material and my connections to it were lost. An act of knowing can never be fully explicit, and the meaning of an act of knowing depends on the constituents tacitly known by the knower. Unable to interact and give form through direct material manipulation and gesture, I couldn't pull my deep tacit knowledge. So in this case, the act of knowing depends on direct interaction with the material. The maker tacitly knew, but became inaccessible due to the nature of the flat digital interface. Shifting to a more immersive interface like in the VR as a new form giving tool, I was able to regain my embodied experience. While the physical material was not present in the VR space, this embodied knowing in material practice translated directly to facility for making knots virtually. Embodied knowledge as knowledge in the hands is forthcoming only when bodily effort is made and cannot be formulated in detachment from that effort. Here comes the conclusions. Arguably, this work is an example of the extended mind at play. So the outcomes show how knowledge is gained and shared through the experience of working together. Knowing extends beyond the individual in order to accommodate broader cognitive events that include interactions among people, artifact, space, and time. Working alone, the outcomes detailed like in this talk wouldn't have been created. So through shared acts of knowing, each practitioner-researcher's understanding of the crossing over from analog to the digital practice was expanded. Handwork and practitioner-researchers' own tacit knowledge continues to blur the line between the analog and digital, exemplifying the opportunities for emergent collaborative post-digital fabrication. That's it. And here is the references of the citation made in this talk. So you can take a look if you are interested in. And for further reading, I just published an article in Craft Research Journal, basically about the project that I just gave you a talk. So that's it. Thank you. So any questions at this point? I'm going to stop sharing my screen.
Thank you, Dr. Nimkulrat. So now I'm going to open up the floor to the audience for questions. And let's see if we have any.
I saw some hands.
Yes, that's what I'm looking for. Apologies, I don't know who raised the hand, but you're, oh, Glenn.
Yeah, Glenn.
Yeah, Glenn, go ahead and unmute yourself and turn on your camera and feel free to ask your question.
Hello.
Hi.
Lots of questions. Thank you very much for the presentation. The hand-drawn segments that you did in VR, were you able to draw really exact versions and then clone them multiple times to save yourself a lot of time when you were doing that? Or did you have to hand draw the whole process?
I didn't get the exact shape of the knots, but I could get the interlocking of the knots, and that's a key thing that I struggle on the 2D screen. So I needed to reshape the how to say the curve of the strands basically.
But were you able to draw that really good one time and then just duplicate that over and over and over again?
Yeah,
So
exactly. Yes. Yeah. I do it just one time. So I spent basically 2 half days.
And then what kind of software were you using in the VR side?
Oh, I use Gravity Sketch.
Oh.
Well, you know, it was so funny because when I entered the VR lab and I asked how can I draw in VR, and it was like, oh, well, no one knew. And then and the technician there started searching, and then he found this Gravity Sketch as something he recommended to me because it was the easiest one for a beginner. So I adopted it quickly. So we kind of bought it quickly and just use it.
And then what was the learning curve of you having to learn Gravity Sketch before you felt comfortable drawing in that environment?
Actually, I think it was a very good recommendation because it's super easy. So it's like, it was super easy. I learned it in 10 minutes. It's basically 10 minutes.
Have the same luck, but.
So I wouldn't say that to me, it was super easy. Yeah. Because the most important point was about understanding where all the strands, because to construct a knot, I need 4 strands and they need to be in certain position in order to interlock perfectly. So by being able to be in that space, it's already helpful to see all the positions in 3-dimensional space.
Thank you very much.
You're welcome.
So Kayla, sorry, was supposed to be anonymous, but she is a team member with KPU VR lab, says, I wish all tools were that easy to learn.
Actually, it wasn't that difficult. If you think that the whole process that I learned the whole thing, it was only 2.5 months, I wouldn't say that it's too difficult to learn.
That sounds great.
I don't know. Just start doing it, and you will realize that it's not that difficult.
Okay. So feel free to follow up with another question if you have any. Oh, we have Jim Rahman here that would like to ask a question. Go ahead, Mr. Rahman.
Hi, apologies for the background noise. Hopefully you can hear this. This is great. I love your website. You're sitting presumably somewhere in Toronto because that's where OCAD.
That's right. Yeah.
Many of us. I happen to be in Toronto, but most of your audience is in Vancouver and Surrey. Do you have any thoughts on just collaboration and working with others? Toronto is obviously the commercial capital of Canada, but and maybe life is easy here compared to other places in Canada. Do you have any thoughts on how people in the craft, VR craft, anything that you've been dealing with, how difficult or not it is outside of the big city?
It's a tricky question, you know, because to get a collaboration to work, it means that all the collaborators should somehow have similar goals or similar understandings. And in my case, it was in a way lucky that my collaborator is also a craft practitioner, even though his expertise is in a different kind of material domain, but still. So, well, it's difficult to comment on this because I find that collaboration is, to start it, it's really based on luck, but then to maintain it, it requires a lot of soft skills and kind of be open-minded and listening more than usual, because it's about gauging each other's understanding, and even vocabularies used in different fields are different. So it's about relearn and de-learn and relearn new thing. It's like you give up, in a way, your own vocabularies a little bit in order to learn new things. Like when I started this collaboration, I don't even know how to call strands in 3D modeling software. It's a different vocabulary, even though we actually means the same thing. So that's why I mentioned at one point that like fundamental tools like drawings and demos are helpful, because sometimes words can't explain much, but once you draw, it's easier to understand. So in a way, art and design people sort of have benefits in that sense, because we use it all the time.
If I could just add a quick follow-up then.
Yes, please.
Collaborating across space. So, you know, you've got, I'm sure in OCAD, there's plenty of shared spaces where people are coming together, working overnight perhaps. But is the reality now that using software collaboratively and remotely, is that good enough? So if you're collaborating with the partners that you have, very well noted on the maintenance part, there's a serendipity piece, which is just starting it, maintaining it, but then doing it locally and remotely. Is technology providing that, closing that gap?
Actually, it's difficult for me to comment on this, because this collaboration based on like physical collaboration, like being in the same space. So I'm not sure how, if I would have done this remotely, how it would play out. Yeah, because it requires like, that's really tricky. Well, maybe I can answer these questions once I started a new collaboration, like very practice-based like this, because otherwise I had another project in which I collaborated with mathematicians, and it was always like remotely. So it was about sending back and forth what we wanted to do and sending different readings, different models. And it's about like communicating back and forth, but it's not real time.
Appreciate it. Thanks very much.
My pleasure.
Thank you for your question. We also have in the chat, our guest says, my experiences with tools like Unity, and while that's considered easier than the most, it still has a learning curve. I also find it fascinating that language and communication plays a role just as important as any other software or tool. It's actually, it's a team member.
Yeah. Is that a question? Or it's more like
I believe like it's a experience, opinion, and a comment.
It's more like, I share the same experience. Yeah, definitely. Thanks for the comment.
I have a question for
Yes,
you,
please.
Doctor. So for all these creative arts and stuff, has there ever been a time where like that cup, right? Like that cup that you made with a mold. So with all this art, where do you put it to use? Like how does...
Well, this is a good question. I would say that it's because now these are more like, because right now my creative practice was framed within the framework of a research project or whatsoever. So like, for example, this project, I frame it within a research project. So meaning that whatever I created in this project is an evidence of how I employ material practice in order to address research questions. So these are like the resulting physical outcome of research. And so I put it to use in relation to, like, for example, paper writing. So that's one channel. And then the second channel is like, of course, these are like exhibited in different exhibitions. Mm-hmm. So that's the second one. And in terms of use, like use, like, for example, the last phase of this project, it was about casting porcelain cups. So of course, those are my kitchen, very practically.
Now used for tea.
Yeah, of course. So in a way, if I would like to grow it into like products that I could commercialize, that's a feasible product, but I didn't go down that route.
So is it more expensive to make them, or is it more economical?
It's difficult to say, but because with this method, there is no positive cup being made in the very beginning of the process. So, okay, to explain you a little bit, like for ceramic slip casting, you need to make like a positive cup first, using plaster or other kind of clay, and then you make a mold. So this cup become useless afterwards. So with this process, the positive cup doesn't need to be made. So in a way, it saves the time to make that positive cup. So in that sense, saving time could be like, would mean less cost. And otherwise, yeah, the mold could function just like plaster mold. So I don't see much difference after the first cast that I mentioned that it took very long time to let the clay set, but it was because the mold itself wasn't like, it took so long to completely dry. So even in the first casting, it wasn't really completely dry, but after several times that I cast and I let it dry, it becomes faster.
Okay. Thank you for your answer. I appreciate it.
Pleasure.
I would also like to remind everybody that you can type in your questions into the chat and I can read them out anonymously. Or you can raise a hand. Again, there's the icon up top where the smiley face is with a hand, and I can call out your name. You can unmute yourself and turn on your video and ask your question yourself. Okay, we have a person with a raised hand. Glenn Downey again has a question. Go ahead, Glenn.
Hey there. I was just wondering also then, what was the time frame to iterate between thicknesses of the strands you created? So as you were printing the 3D printouts, how long did it take you to figure out that this is the thickness of the filament that needs to be printed, and this is the material that works well, and this is the material that doesn't?
There are two parts here. The first part was about the exploration of the thickness. That one was only 1 day. But when moving to different materials, I mean, different composite filaments, that took maybe 3-4 weeks, because it was like a juggling between redoing or readjusting the 3D model and also the slicing software, and then print. And then once I get a successful print, I need to prove it again if it's really successful. So the second print, and if the second print didn't turn out well, I kind of go back to readjust the model, readjust the styling software. So that part took longer time.
All right, we have another question from Dr. Farhad Dastoor.
That was fascinating, Nithikul.
Thanks.
And what's really interesting about the project was you framed it as a research project. And research has multiple goals and multiple meanings. And one of the goals is to answer a question. It could be a theoretical question, it could be an applied question, it could be an artistic question.
Yep.
But we often find as researchers that one of the goals of research is to generate new questions, not just answers.
Mm-hmm.
And so I'm wondering what questions came to you at the end of this process that you didn't have at the beginning?
Oh, actually, I would say that the question kept changing until like the last phase before I kind of found VR. Like, for example, the two research questions that I put, that I presented, the VR part came later. So it was like, in a way, a reformulated question. So that was one thing. And then at the end of the process, I think one question that came to my mind was that, how about if this project was a collaboration between more people and like bringing in another angle to explore it? Like, for example, the VR lab manager, if he would involve in the project in the beginning, would I get something more interesting? Like, for example, because once I could succeed in printing the flexible loose knot, it was the end of my time there. And I was thinking that if I could create the 3D cup with flexible knots, like I achieved in one section and multi-sectional knots, that would be something to try. But so far I haven't tried it. So I could frame it as a question like, what if I draw or I create knotted cup fully in VR and print it? Will I get a flexible loose cups at the end? So it wouldn't be a rigid cup. It would be a more like a little bit flexible cups. I would imagine, but I haven't done it.
Interesting. Thank you.
Welcome.
Thank you for your question. Any more questions? Okay, it's a lucky day for me because I get to ask one more question.
Please.
So what kind of exhibitions do you display this art? Because I'm in Toronto, so I can come and see.
Right now they're not anywhere. They are in my cupboard. The next exhibition, I'm going to send them off to Estonia because there will be an exhibition of like retrospective, like former faculties who used to work in the academy. So I was invited. So I'm going to show these prints there, and it will be in November. So otherwise, well, it depends on the theme of exhibitions to kind of select work to show, but that's the only exhibition I have for this work so far.
Yeah, also because of COVID-19, I believe everything is so unpredictable that people are not getting a lot of platform to display their art.
Yeah, that's very true. Yeah, like especially in my area, everything is physical, like physical objects, right? So you need to see the real thing in a space.
Absolutely.
So when everywhere there is no access, so how can you experience like material objects? So
yeah. I 100% agree.
Mhm.
All right, I would again like to remind everybody you can either type your questions in the chat or raise your hand. And we have a raised hand from Mr. Rahman. So go ahead and ask your question, please.
You have a few keeners on this call.
Yes, that's good.
It's just a response to this last piece with Simi's question. I'm in Toronto too, so for exhibitions, just a thought, because of the number of buildings that are going up, particularly commercial buildings. So about a week ago, I was in CIBC Square, which is the first phase is just about to open. And it's got some great pieces in there on the boreal forests and glass that's many, many feet high. That space, and there may be other spaces, and this is worth knowing, I thought for back in Surrey and Vancouver too. These spaces are crying out for creativity. Not that the creativity hasn't gone into the spaces, but then it's just there. So I would encourage some reaching out, and I may have a contact for you there that might help.
Oh, nice.
My wife's just written an article on that space. But anyway, just a thought, because I don't know that this would necessarily cost other than just the cost of putting it up, but you're dealing with some pretty wealthy backers, to the developers and tenants there. So
okay, that sounds great. Yeah. Even if it's not for myself, it's good to know for my students as well.
No, exactly. And I think this is a useful kind of idea for anybody who wants to exhibit. It's just that obviously with these spaces, there has to be a coincidence of needs, the reputations and so on needs to kind of align. There's a few stars that need to be lined up, but I don't know. Give it a go.
Yeah, sounds great. Thanks for your recommendation.
I believe somebody else came online and they had a question. I'm not sure if they still have a question or if we answered it already. Okay, I do not see a question here. Any more question, guys? Okay, we do have a... Okay, Dr. Lesueur.
There was something very familiar about those cups you made, Nithikul, and it just occurred to me what it was. So my mother makes these gingerbread houses for Christmas.
Ah, yeah.
But instead of using gingerbread, she uses icing.
Yeah.
So the entire structure is see-through. It's all white lattice work icing. I still don't understand how it stays up. Because it's so intricate and three-dimensional, and the icing hardens, so it's not your material. But it struck me that what she's doing is very similar to what you're doing in this sense. Both taking very traditional old craft, knot making, weaving, right? The construction, sculpting. But you've brought new technologies and new methodologies. And out of that, something fascinating is happening. And I'm just curious what your thoughts are about interweaving the new with the traditional and the old.
Yeah, that's something that I would love to explore. Because interestingly, I need to tell you a little bit my background, because I study industrial design. So I work a lot with weaving technology, like with the latest machines in the world. And then when I move into like craft at the start of my PhD, just for some reason I was fascinated by using craft as the means, because I wanted to understand the meaning of materials. So basically I went back to craft, and the technique that I'm using now was basically the technique that I learned when I was 10 years old. So in a way, I combine like something from my past with something in the present. Well, the reason I'm telling you this is that it's in my passion and in my thinking that whatever we learn a new thing, that we can't leave our tradition behind. It's always in us, and whenever we need it, we somehow have it equipped in ourselves. So that's something to pick from the memory. So yeah, of course, like weaving new and old.
Yeah, when I was a little boy, I played with Lego a lot. And now everything I do, I view it as just more complicated Lego.
yeah, you see, it's in us, and we can't really leave it behind because we already learned it. We can, yeah, but I would love to see your Martha gingerbread house.
Yeah, I'll send you the photos.
Yeah, nice, thanks.
Thank you.
Dr. Dastur, some actual gingerbread for me, please. The eatable portion, please.
That also can be arranged.
The photos will only make me hungry. All right, we have another question from Mr. Rahman. So go ahead, Mr. Rahman, ask your question.
Hi, I'm interested in the very expensive kit that OCAD has. So the 3D printers and potentially the software licenses as well. With a sort of accountant's hat on, because I'm sure the administration is looking at getting the most value out of these assets. How do you do that? I'm sure there are individual questions that these assets help work through for individual researchers, but for students, for researchers, if I can abstract up just from your own use to the institution's use of this equipment and software, how does it kind of address that?
I would say that if you were a student at OCAD, you can access to software very easily because it comes as a package once you enroll into the institution as a student. And in terms of access to the fabrication studio, students have more power than a faculty like myself. So if I really want to use 3D printer at OCAD, I needed to kind of book time or wait it until no students needed to use the machines. So students get priority. So I would say that, I don't know if I'm answering your questions, but I would say that students really, if they want, they can get really good access to the fabrication studios, and software is basically up to them if they want to download or not. And there are a lot of tutorials. And in our curriculum, there are always like courses about using different software to design or to make, like, as part of the production process.
And from your understanding of the physical equipment, is the lifetime, with technology changing at such a pace, do the institutions tend to get the value out of it in time before you get another cohort of students that looks at this thing and it just looks dusty and old because there's a shiny new thing?
Yeah, that's a good point. I would say that these machines, I mean, the technology gets old within 3 years, basically, maximum 5. So, and I would say that, well, I don't think at OCAD we update tools quickly enough. So we're still using like machines that are quite outdated already. But you brought a very good point. So of course, still like a cohort that came after those who could experience like brand new machines, of course, would get totally different experience, because the machines wouldn't work like perfectly well, or I mean, that, well, like in the fabrication studio, sometimes there are machines that are not working, or they have to wait longer because the number of machines are not as many as the previous year, for example. And the maintenance could take, couldn't really cover the machines to run well. So it's always tricky to work with technology because it goes so quickly and it requires a lot of maintenance. And of course, it comes with cost.
Okay, that's a good insight to have. Thanks.
Thanks.
Thank you for your question. Now, if I could please request all our guests towards the chat, the meeting chat, and we can all look at the art that Dr. Thestore's mom makes. He has shared the pictures with us.
Mm-hmm. I think I couldn't see the chat.
The chat isn't visible to the people in the audience.
Oh, okay. I'm very sorry about that. Is there a way we could share it over here? Apologies, I cannot make it work. Well, whoever wants to see the pictures can contact me or Dr. Thestore, and we'll be more than happy to send you the pictures of the gingerbread house with frosting. Any more questions, please? Again, I would like to remind you can either type out your questions. Oh, yeah, we have Karen Davidson that would like to ask a question. Go ahead, Karen.
Hi, Simi, thanks. Just along the lines of the gingerbread house and food. Myself, I'm a dietitian by background who's wanting to get into the use of virtual reality with related to food and nutrition. And so in this discussion about the gingerbread house and seeing the work that you've done, I'm wondering, you know, have you ever worked in that sort of space or familiar with any of this kind of work that's done in the food, nutrition, you know, food models perhaps used in virtual reality? Any comments there?
Well, I have quite limited experience. That the only experience I have is to 3D print chocolate. So when I was in my previous institution, so we were exploring like how to build like a 3D printer for fluid material. So we tried with chocolate. So that's the only. So but it didn't involve any VR. So it's more like digital fabrication of food in a way. Yeah, but I think that's a very good idea because in VR you can create like, you can see or you can create food, like the form of food over there. And then, well, I mean, with my method, it could be then translated into like 3D form and then print it. That would be something beautiful to eat. Maybe my next project could somehow deal with food because I like cooking myself. So maybe that's something fun to do.
Great, thanks.
Thanks.
Thank you for your question. Dr. Thestore has a question.
Not a question, but if I screen share, I wonder if everyone can see the photo that way.
That would be very nice.
Let me try it.
Maybe your mom could do a tutorial on how she makes them.
Right.
Oh. Ah.
Yes.
Is that
Oh, that's icing sugar, right?
Yes, yes.
Maybe she used that, how to call it, this squeezing tool. That's intricate. Beautiful. That could be 3D printed.
But you can't eat it if it's 3D printed.
Oh yeah, you can. I mean, if yeah, like the machine that I mentioned for 3D printing chocolate. So if it's made like new with the kind of food grade material, you can eat what is printed.
Well, there's an idea for you, Karen.
I like that. That is actually very interesting. Like to actually, yeah, do a model of food and yeah, people's perception of that and eat it. Yeah, I like that. And so you actually used chocolate, did you,
Yep.
to make the model? Oh,
Yep.
wow. Yum. Okay, interesting.
So icing sugar should be possible as well. I mean, need to make it fluid first.
And how long would it take to do something like that? Like,
to make a model and to print, it doesn't take long, but to create a machine, that takes long.
yeah.
So that part needs like technicians and technologists to put all the components together and to source all the parts. That takes long, but once it's done, it's easy to do a 3D model and print.
And what, just a sense of like cost, like when you, so in the model like that you were doing, like what sort of estimate of cost would that be?
The production of chocolate itself, I don't think it costs more than you would have cooked in your kitchen, like melting chocolate and put into molds. I don't think that part costs much. And the machine itself, I don't know how much exactly, but I don't think it costs more than 1,500. Because it's basically like hand fabricated one. So it's like using different parts, and some parts are actually 3D printed and being used.
Okay, thank you.
It's about finding someone to be able to do it.
Thank you for your question. We also have Catherine Sermacheski. I'm very sorry if I said your last name wrong. And they have a question.
Yeah, that's all right. Yeah, just a quick comment, actually. That icing, that beautiful gingerbread house, my grandmother used to do that. And it's called ornamental icing. So it is very rigid and it dries really rigid. So it's not the kind of soft stuff that you put on a cake. So, and I think she's got cornstarch in it, if I remember correctly. But and that's the kind of ornamental icing you use to glue together the gingerbread houses. It's really thick, right? But it would work in a 3D printer. It would be really cool. You could create literally that same kind of thing or something similar by using that kind of icing. I think it'd be very cool.
But Catherine, it wouldn't taste as good.
I know. It's it's sweet and kids don't mind it, but adults tend to shy away from it.
And that's interesting, right? The notion of how something is made and who makes it.
Yeah.
And somehow from her hands versus a 3D printer, there's something is lost, I think.
Yeah. Actually, that's an interesting point. It's about something created like by hand with care versus like created by a machine. Yeah, definitely.
Well, we're getting close to the end of today's fascinating presentation, and I'm sure you're a little bit tired, Nithikul, but probably also stimulated by the great questions. I'll let Simi do the close, but I just wanted to personally thank you for this very fascinating presentation. and to wish you great success and luck in all your future endeavors.
Thanks, Farhad. Thanks so much for inviting me to give a talk today. It's really fun actually to gain like different perspectives from the audience and to get questions that and I usually wasn't asked. So nice. Thanks so much.
Well, thank you, everyone, for being a great audience, for asking all the fun questions. Thank you so much, Dr. Nithikul Nimkulrat, for taking out the time, the energy to present at our speaker series. We really appreciate it. If anybody has any last quick questions, don't see anything in the chat, no hands raised. Okay, so thank you very much. We really appreciate your time and energy and an amazing, beautiful presentation.
I just wanted to say thank you too.
Oh, yeah, go ahead.
Thank you.
Thank you too. That was wonderful. Very
Thanks.
interesting.
Nice to hear that.
All right, I'm going to stop recording now.